For slide 6, we have an inelastic collision that occurs between a sack of coal and a railroad flat car. So, inelastic collision, the equation for that is m1v1 plus m2v2 equals m1 plus m2, and then that is multiplied by our final velocity. So both of our masses will merge to make one object with some reduced smaller velocity. The final velocity in any inelastic collision should be smaller. It should slow down. Alright, plugging in our numbers, we know 2,000 times 3 plus 500 times the velocity of this sack of coal is going to be 0 because it's falling down vertically. It's going to have a vertical velocity, but that's not going to impart any momentum onto the cart. And then we'll do the sum of mass, so 2,000 plus 500. Close off our parentheses, and then our final velocity is what we'll ultimately be looking for. So if we clean up the math, this gives us 6,000 equals 2,500 times VF. And so the last step to find VF is 6,000 divided by 2,500. And that's going to give me, 2.4.